We're at question 5 of the January 2024 CSEC Mathematics past paper. Now, it says here, the mass M in kilograms of 120 newborns at a hospital is recorded in the table below. So you have the figures here. So this question is on the topic statistics, all right? So it says state the modal class. What is the modal class here? Remember, the mode would be the item that is there more often than the others, right? It's the highest frequency. So the modal class would be 4.4 less than M less than 5, less than or equal to 5.3. So in that case, it is 4.4 is less than M, 4.4 is less than M, less than or equal to 5.3. Is it 5.3? Yes, 5.3. So that is what you should write down for the answer. State the modal class. Alright? Now, this is part A. 1. Part A2 says to complete the table below and calculate an estimate of the mean of the 120 newborns. So here now, how did they get these values? So you need to know how they get the values that they have so you can find the new values. Let's copy this and paste it over here. We're going to fill it out over here. So now, they have the midpoint, 3.05. When they get the midpoint, what you can do is find the average of the endpoints. They have 2.6 plus 3.5. My, his pointer should have 0.5 equal. And if you put that over 2, 3.05. You see that? With a frequency of 7. Alright? If you do this, the same thing to 3.5 plus 4.4, put it over 2. Right? 3.5 plus 4.4. You get that over 2. And you divide by 2, you get 3.95. And so on and so forth. 4.4 plus 5.3 equal that over 2 equal 4.85. So to get this now, this value now, that this you should get, you're going to have 5.3 plus 6.2 equal. See that? Divide it by 2 and you get 5.75. So beside the 6.2 thing, you're going to have 5.75 right there. About the 7.1 to 8.0. You have 7.1 plus 8 equals 15.1. Divided by 2 and you get 7.55. Alright? So what you have here is 7.55. Alright? Then over here now, they say you must have frequency time midpoint. Let's do what you have here. 3.05 multiply by 7, that's the midpoint, multiply by the frequency, and you get 21.35. Alright, see that? So to get this, you multiply the number you get by 29. What was it again? 5.75 times 29. That's what you're going to get. Alright? So it's going to be 5.75 times 29. It's 29, right? Times 29 equal 166.75. And the other one will be 7.55 times 8. So you have 166.75, 60.4. 166.75, 60.4. So you have your values filled out. You completed the table. Well, they say complete the table below and calculate an estimate of the mean mass of the 120 newborns. Now remember, they want the mean. And by the way, pause the video and work out that part and let me see what you get. Alright? You paused it, worked it out. Now, you can type your answer in the comment section from now before you watch and you work it out. Alright, so let us see. First of all, there are certain things that some students might make a mistake and do, but you're not supposed to. Let's look at it over here. You're not supposed to say 3.5 plus 3.9 plus 4.87 plus 1.85 plus 5.75 plus 6.65 plus 7.55 divided by how much? 1, 2, 3, 4, 5, 6. You're not supposed to add up these numbers and divide by 6, you know. That's not what you're going to do. Right? And you're not going to add up these numbers and divide by 6 either. To get the mean, what do they call it? The mean mass. Right? That's not what you're going to do. Let me just make a note what they want. They want mean mass. Now, remember, the mean, as you know, you add up all the values and divide by the number of values. But how many values do you get? Do you have to add up? 120. Now, here, you see, they have a mass. The midpoint represents the class here, between 2.6 and 3.5, where you have the mass greater than 2.6 but less than or equal to 3.5. Alright? The 3.05 is used to represent this range of mass. How many of them you have? The frequency of 7 means you have 3.05 plus 3.05 plus 3.05 plus 3.05 plus 3.05 plus 3.05 plus 3.05. That's what it means, you know. And then the 3.95, you have 18 of them. So you say plus 3.95 plus 3.95 and so on, 18 of them. But instead of having 120 of them lined out like that, they have it neatly put in a table. So when you say 3.05 plus 3.05 plus 3.05 plus 3.05 plus 3.05 plus 3.05 plus 3.05, is the same thing as saying 3.05 multiplied by 7, and you get the 21.35. So what I want you to do is work it out that way, right? And tell me, well, you can put in the comments what your answer is. That's what you should do. If that's not what you did, you can go ahead and do it now. All right. So here, the mean mass, you can write it like this. M is used to represent mass, so the dash above it is the mean, is equal to, is going to be the sum of f of x, the sum of fx, I mean, the sum of frequency times x, divided by the sum of the frequency. Well, the sum of the frequency would be how much? 100 and how much? Let's say 120. So when you add up these numbers, you should get 120, right? The frequency, the sum would give you 120. So what you would get is this, my calculator. Let me try and get back my calculator here. Calculator, where are you? Where's my calculator? Alright, my calculator here. Alright, so the fact is, if you add these up, you have 7 plus 18 plus 30 plus 29 plus 28 plus 8, and that would add up to 120. This is where the 120 come from, right? So anyway, what you should have done is to say 21.35 plus 71.1 plus 145.5 plus 166.75 plus 186.2 plus 60.4, and all of that divided by 120. That's what you would have. So let's get back to our calculator and see how that itself would work out. Calculator. So here now, what we have is 21.35 plus 71.1 plus 145.5, right? 145.5 plus 166.75 plus 166.75 plus 186.2 plus 60.4 equal 651.3, and then 651.3 divided by 120 gives us 5. Let's round it off to 428. 5.428. Could write to 3 the small places if you want. 5.428. So the answer for that, the mean mass is equal to 5.428 kilograms. They have it in kilograms, right? Yeah, kilogram. So that's that. After that now, what do they ask for? Okay. One newborn is chosen at random from the hospital. Find the probability that the newborn has a mass greater than 5.3 kilograms. Let me just copy that part and put it over here. Now, what I'm going to ask you to do, pause the video and work out this part. Let me just erase these things that I have here. This was what? 5 point how much? My 5.428. So let me write it up here. Mean mass equal 5.428 kilograms. Yeah, so I want you to work this part out. Alright, you worked it out. And in fact, it would be good if you work out, do your best to work out the entire question before watching it, right? So, what I say, one newborn is chosen. At random, find the probability that a newborn has a mass greater than 5.3. Now, probability. One way to put it, here, let me put it in my own words. The probability of X occurring would be how many X's that you're looking for, all right, how many of the kind of X's you want. So, the sum of X's that are wanted divided by the sum of all X's that remain, that you have available, right? So here, that's just my way of putting it. You have some more elaborate, eloquent definition of probability lying around in books and on the internet. But anyway, here, how many newborns are greater than 5.3? Those are what you specifically want to look for. So you want all the newborns greater than 5.3 kilogram. What you need to do is look at this. You see, all of these are less than 5.3. These are from 2.6 to 3.5. These 18. You have 7, you have 18, less than 5.3. Don't start counting it. You see this, these 30, they are from 4.4 up to 5.3. What it says, less than or equal to 5.3. The question asks you, greater than 5.3. It must not be equal to 5.3, but they must be greater than. So, this now is where you start counting up how many are greater than 5.3. This is 29, because M is greater than 5.3. So these are greater than 5.3. So 29 plus 28 plus 8. So this is 29 plus 29 plus 28 plus 8 of them are greater than 5.3 divided by, and then all X's, all newborns is 120. So that's going to be the probability. So what do you have now? what you're going to have here. Let's just use our calculator and work it out. So calculator. So we're on here. All right. So what we have here is 29 plus 28 plus 8 equal 65. And then we say 65 divided by 120. 65 over 120. Alright, we want it as a fraction, so don't put it as any decimal on any point, especially when it's a recurring decimal like this. It can be in percentage or a fraction, but since the fraction doesn't give an exact value, leave it as a fraction. 65 over 120. So you have 65 divided by 120, or in this case as a ratio. 5 into 65, what do you get? 5 into 6 goes 1 time and 1, 5 into 15, 3. It's 13 over 5 into 12 goes 2 time and 2, 5 into 24. 13, 24, 13 over 24. 13 divided by 24. So you can write your probability as a fraction like that. Alright? So that's your answer. Alright. Now we have part B. Complete the cumulative frequency table below. Let's deal with that in another video.